Hi everyone, myself RM Arish Pawan, studying in 7th semester in Department of AI in Venkateshwara College of Engineering. Today I am going to explain about clustering. The outlines are what is clustering, supervised and unsupervised classification, types of cluster algorithms, areas of applications, and discussion and results. The clustering definition, the process of grouping similar items together. Cluster should be very similar to each other but should be very different from other clusters. We can say intercluster similarly between objects is and high intercluster similarity is low. The supervised and unsupervised cluster classification. Types of clustering algorithms are clustering has been popular area of research. Several methods and techniques have been developed in determine language process, grouping among them objects. Types of clustering: hierarchical clustering, partitioning clustering, and grid-based clustering. Clustering algorithms used in machine learning and algorithm for high-dimensional data. And these are the as shown in the diagram. It is divided into many parts. Classification versus clustering. In classification is a supervised learns a method for predicting instance class from pre-labeled. Clustering. Clustering is a unsupervised learning finds natural grouping of instance given unlabeled data. Cluster evaluation. Manually inspection benchmarking on the existing labels. Cluster quality measures distance highly similar within the cluster, low across the cluster. The distance functions. The simplest case, one numeric attribute and distance xy is equal to a of x minus a of y. Are all attributes equally important? Weighing the attributes might be necessary. The simple clustering, the k-means, work with the numeric data only. Pick a number k of cluster center at the random. Assign every item to its nearly cluster center. Move each cluster center to each assigned. Repeat step 2 to 3 until average. K means example step 1. This is shown in the diagram. Example 2. Squared error criterion are the k-means algorithm with Euclidean distance measure is equivalent to minimization of a squared errors criterion, where E is the sum of square error for all object in the database. P is the point in the space correspondence to given object and Mi is the center of cluster. Donates the distance of the object. Cluster center it belongs to this, therefore makes the cluster as compact separate as possible. Pros and cons of the K-means work then well data from compact clouds well separated from one another. Method is cleared, scalable and quite efficient for the large data sets with complexity where K is the large number of clusters, objects and T number of iterations required. Usually can be only the applied where the mean of cluster is defined. If there are categorical data, this might not be possible. User may not be able to select a good value. Algorithm is sensitive to noise outlier point can influence the mean attribute value sign significance. K mean variations. K medoids instead of means. Use medians of each cluster. Mean of 1, 3, 5, 7, 9, 5. Key medoids. This method is less sensitive to outlier than the k-means. Each cluster is represented by most central object in cluster. We still minimize the sum of dissimilarities between each object and its cluster reference point. K-medoids algorithm randomly choose k of the n data objects as medoids. Repeat. Assign each of the remaining objects to cluster represented by most similar medoids. Randomly choose a non-medoid object. Consider each of the current medoids. Compute the total cost of swapping with random until no changes. Evaluating the cost of the swapping medoids. It is non-medoid O random good for replacement of medoid OG. Evaluate these cases for each non-medoid objects. This is the diagrams of swapping medoids. Four cases. Case 1, case 2, case 3. Case 1 belongs to medoid. It replaced by as medoid and P is closest some other medoids than P. As same as medoid and P is closest to case 2, then P is reassigned to a O random. Case 4 belongs to medoid OI which I is not equal to j if OJ replace O random as medoid and P is closest to O random reassigned to O random. Total cost of swap. Each reassignment determined as above case causes a difference in square error E to be contributed to the cost function. The difference may be positive or negative. The total cost of swapping S is the sum of the all cost from non-medoid objects. If total is negative, the swap is worth while doing. K means clustering summary. Advantages and disadvantages. Simple and understandable advantages. I, items automatically assigned to clusters. Disadvantages are must pick number of clusters before and all time into clusters to sensitive to outliers since an object with an extremely large value subsequently dissolve the data. The types of clustering hierarchical clustering, partial and supervision clustering, partial supervision of clustering, two dimensions Such problems are effective and efficient methods of clustering, scalability, handling different types of data, complex shapes of cluster, subspace clustering, cluster overlap. Example of cluster application used in marketing, astronomy, earthquake studies, in genomics. Cluster summary. Unsupervised many approaches came in simple, useful. K method less sensitive to outlier. Types of clustering hierarchical works with symbol attributes can be used in fill of the values.